Hello students, I am Rohini Chogle. Okay, already I discussed about the classical mechanics, in that definition, types, examples, etc. In last class what I discussed, I discussed about the generalized coordinate, generalized displacement and generalized velocity. Okay, so tell me what you mean by the generalized displacement. The last expression, generalized displacement, that is delta Ri equals to summation I equals to 1 to n dou Ri by dou Qj delta Qj. This is about generalized displacement. And generalized velocity is dr by dt, that is vi, that is equals to Ri dot, that is equals to summation I equals to 1 to n dou Ri by dou Qj Q dot j plus dou Ri by dou t. Okay, so please check in your notes. Okay, see students, the classical mechanics is like as your mathematics, so better try to solve. Okay, then you will understand. It is little bit difficult, so try to solve this. Okay, next today I will discuss it about the generalized acceleration. What do you mean by the acceleration? The rate of change of velocity is acceleration. So already we know about the velocity. See here, the generalized displacement, using that equation we solve the velocity. So using the velocity equation, now we will solve the acceleration. Acceleration means the rate of change of velocity. So the component of acceleration are given by the differentiation. See here, Ri dot is nothing but the velocity, that is summation j equals to 1 to n dou Ri by dou Qj Q dot j plus dou Ri by dou t. So the differentiation means d by dt. Differentiate it again with respect to time, we get. See here, Ri dot is already there. Differentiation of Ri dot is Ri double dot. So write this is as it is. Okay, next differentiation, summation j equals to 1 to n d by dt. Okay, first this term, you know that d by dt of dou Ri by dou Qj Q dot j is as it is, plus summation j equal to 1 to n dou Ri by dou Qj as it is, d by dt of second term Q dot j plus d by dt of dou Ri by dou t. Differentiate this one. Ri double dot is as it is, equals to summation j equal to 1 to n d by dt of dou Ri by dou Qj is dou Ri dot by dou Qj Q dot j is as it is, plus summation j equal to 1 to n dou Ri by dou Qj Q dot j, differentiation is Q double dot j plus d by dt of dou Ri by dou t is nothing but dou Ri dot by dou t. Okay, next step, putting Ri dot and changing index j to k. What it means, putting Ri dot, already we know that Ri dot equal to this much. Okay, see here, Ri dot is only this much and not d by dt. D by dt is, see here, component of acceleration are given by differentiation, so that's why I wrote d by dt, but Ri dot is only this much. Okay, so putting Ri dot and changing index j to k. Ri dot is nothing but changing index j to k means Ri dot equal to summation k equal to 1 to n dou Ri by dou Qk Q dot k plus dou Ri by dou t. In the above equation, means in this equation, that becomes Ri double dot, Ri double dot equals to summation here. First j equals to 1 to n is there, so j equals to 1 to n. Next dou by dou Qj is there, no? So dou by dou Qj, Ri dot is here, means this equation, that is bracket summation k equals to 1 to n. So write it is k, not j. K equals to 1 to n dou Ri by dou Qk Q dot k plus dou Ri by dou t. Next Q dot j is as it is right here, plus summation j equals to 1 to n, this term dou Ri by dou Qj. In this Ri dot is not there. Next Q double dot j plus dou by dou t, Ri dot is there, no? That is dou by dou t, Ri dot is nothing but summation k equals to 1 to n dou Ri by dou Qk Q dot k plus dou Ri by dou t. Okay, next second expression, that's equals to, see here, summation j equals to 1, this is k not j, right, it is summation j equals to 1 to n, summation k equal to 1 to n. See here, dou by dou qj, dou ri by dou qk, that's nothing but dou into dou ri means dou square ri. Next dou qj, dou qk as it is, dou qj qk, q dot k is as it is, okay. Next see here, this term q dot j, okay, q dot j plus, next summation j equals to 1 to n, this term j equal to 1 to n, dou 2 ri by dou qj dou t, means dou by dou qj into dou ri by dou t is nothing but dou 2 ri by dou qj dou t. Next q dot j is as it is plus this term, okay, summation j equals to 1 to n dou ri by dou qj q dot j plus summation k equals to 1 to n, this term, okay, dou by dou t dou ri by dou qk is nothing but dou 2 ri by dou qk into dou t plus q dot k plus dou 2 ri by dou t square, okay. Understood up to this much? Nothing else is there, just acceleration, sorry, just differentiation and rearranging the terms and putting ri dot. Next summation next see here, that is equals to summation j equals to 1 to n, okay, right, dou 2 ri by dou qj into q dot j, dou 2 ri by dou qj into q dot j, that is equals to 1, means qj equal to qk. See here, dou 2 ri by dou qj into dou t, okay, that means dou 2 ri by dou qj dou qk, dou 2 ri by dou qj dou t, okay, that's equals to 2 times, means 2 times of summation dou 2 ri by dou qj dou t into q dot j, okay. Next next sorry, j equals to k is there, no, first write, see here, summation j equals to 1 to n dou ri by dou qj into q double dot j, sorry, it is q double dot j, no, it is q double dot, change it is, okay, summation j equal to 1 to n dou ri by dou qj q dot j, this term, okay, plus summation j equal to 1 to n summation k equal to 1 to n, this term, okay, first write this term, next this term, next this and this, dou 2 ri by dou qj dou t q dot j is nothing but k equals to j, then qj equals to qk means 1 plus 1 2 times, okay, next plus dou 2 ri by dou t square, okay. So see here, don't be get confusion, summation j equals to 1 to n, k equals to 1 to n, this term right here, this term, okay. Next qj equals to qk means this plus this equal to 2 times of this much, next this term as it is, next this term as it is, okay, this is q dot k not q, so q double dot k not q dot, this is about the acceleration. So clear, generalized acceleration. So before going to acceleration, first try to solve the displacement, velocity, then you will know about the acceleration. So directly acceleration will not come, because acceleration is depending upon the velocity, velocity is depending upon the displacement, okay. Now generalized force, generalized force means what? Force, let us consider a force, that is summation vector fi acting on a system of n particles, that is summation vector delta ri be a small displacement of the system. The work done by the force is given by, already we know that the work done equal to force into displacement. The basic definition, work done is delta w, that is equal to force means summation fi into delta ri, that is force means fi, displacement means delta ri, you know that displacement delta ri, that is equals to summation fi delta ri means generalized displacement, you know this equation, summation j equals to 1 to n dou ri by dou qj into delta qj, that is summation j equals to 1 to n summation, see here, take f in the bracket, summation fi dou ri by dou qj delta qj as it is. Next summation j equals to 1 to n capital Qj delta Qj, This is the symbol, means where qj is nothing but summation j equal to 1 to n fi dou ri by dou qj, nothing but this term is representing as a capital qj. Okay, represents the jth component of the generalized force in Cartesian coordinates. In Cartesian means x plus y plus z. Already x, y, z, you know that. That is qj. Qj is there, no? Qj. In Cartesian means summation. Fi means first x term ix dou xi by dou qj plus fiy dou yi by dou qj plus fiz dou zi by dou qj. This nothing but x, y, z dou ri by dou qj. Generalized displacement, I solved that. Okay, so be prepared, generalized displacement and velocity. Next, if a particle is defined by r theta generalized coordinates, then the components of forces are given by F equals to Fr r cap plus F theta theta cap. R cap and theta cap are unit vectors. You know about the unit vectors x cap, y cap, j cap. Same Fr r cap plus F theta theta cap. Where r cap and theta cap are the unit vectors. Capital R equals to r into r cap. The generalized coordinates with r and theta coordinates are qr equals to F dou r by dou r. F dou r by dou r means Fr r cap plus F theta theta cap. Dou r by dou r cap it is. Okay, r cap, that is capital F of r. Same in theta term means F of here. R means Fr by r, this r. Theta means Fr by this theta. Fr of r cap, F plus F of theta theta cap, r dou r by dou theta, that is r into F of r. Okay, this is just F of r, this is r into F of r. This is about the generalized force. Okay, so right up to this much, this is generalized force. Next, generalized potential. What do you mean by the generalized potential? See, students, the classical mechanics you will not understand in only first step. Better you try to understand it once or twice. Please try to practice it. Otherwise, it will not understand. It is difficult chapter. Next, generalized potential. If the force acting on the system are derivable from scalar potential V, depending on the position only, then V is the potential energy of the system. Then the work done by the force on the system in an arbitrary displacement delta Ri of the system as, this is work done delta W, that is equals to minus delta V, velocity in negative coordinate. Okay, because if the force acting on the system are derivable from scalar potential V depending on the position only, then V is the potential energy of the system. Then the work done by the force on the system in arbitrary displacement delta Ri of the system. Arbitrary system means negative. Okay, that is equals to minus summation j equals to 1 to n. Velocity, you know that dou V by dou x delta xi plus dou V by dou yi delta yi plus dou V by dou zi delta zi, that is equals to minus summation k equals to n dou V by dou qk delta qk. Okay, q means x, y, z. Already I discussed this in the velocity, generalized velocity. So please see there in generalized velocity, then you will understand. Okay, in 3-dimensional means summation k equals to 1 to n qk delta qk. Qk is nothing but minus dou V by dou qk, that is capital Qk. Delta qk is delta qk. The definition of qk or generalized force is a natural one. Dou V by dou qk, that is equals to summation I equals to 1 to n dou V by dou xi by dou qk plus dou V by dou yi by dou qk plus dou V by dou zi by dou qk, that is equals to minus summation I equals to 1 to n fi dou ri by dou qk, that is nothing but minus qk in generalized force. Okay, when the system is not conservative, we define the generalized force qj associated with coordinate qj. associated with the coordinate qj. Qj equals to minus dou v by dou qj plus d by dt of dou u by dou qj, where u may be called the velocity dependent potential or simply generalized potential, since it gives rise to generalized force qj. So here students, you try to solve this one. Okay, whenever the class starts, I will revision you people, because it is difficult chapter, you will not understand, but don't get choice for this chapter because this is very easy one. Okay, next, generalized kinetic energy, last one. Let r of theta be the polar coordinates. Polar coordinates means x equal to r cos theta, y equal to r sin theta, you know that, of the particle under considerations. Then the equations of transformation are given by x equal to r cos theta, y equal to r sin theta. The velocities of the particle along x and y axis are given by, yeah, means differentiation, x dot, see here, x equal to r cos theta, x dot means first r cos theta, say two terms are there, r is 1, cos theta is 1, u into v. Okay, differentiation. In integration, u into v is not there, integration by parts, but it is differentiation, r into cos theta. R means r dot, cos theta is cos theta plus r, differentiation of cos theta is minus sin theta into theta dot, that is equals to r dot cos theta minus r theta dot sin theta. Next, y equal to r sin theta, y dot equals to r is r dot sin theta as it is plus r sin theta is cos theta and theta dot, that is equal to r dot sin theta plus r theta dot cos theta. Understood? Then already we know that kinetic energy is equals to 1 by 2 m x dot square plus y dot square. This is easier one, equals to 1 by 2 m as it is, x dot plus y dot means this 2 square, that is r dot cos theta minus r theta dot sin theta square plus r dot sin theta plus r theta dot cos theta square. 1 by 2 m as it is, a minus b whole square, a square r dot square cos square theta plus b square r square theta dot square sin square theta minus a into b 2r r dot theta dot sin theta cos theta plus this plus a plus b whole square, a square r dot square sin theta sin square theta plus b square r square theta dot square cos square theta plus 2ab 2r dot theta dot sin theta cos theta. Next, 1 by 2 m r dot square cos square theta plus r square theta dot square sin square theta plus 2r dot theta dot sin theta cos theta plus this plus r dot square sin square theta plus r square theta dot square cos square theta plus 2r r dot theta dot sin theta cos theta. Next here 1 by 2 m, take r dot square as a common. Next, cos square theta plus sin square theta, this one. Okay, next plus r square theta dot square, this term, cos square theta plus sin square theta. Next, this is minus, this is plus, both are same, so cancel this. Next, kinetic energy equal to 1 by 2 m r dot square plus r square theta dot square, because sin square theta plus cos square theta equals to 1. Okay, this is simpler one, no? So what have we discussed? Generalized acceleration, force, kinetic energy, and this one is generalized kinetic energy. Okay, up to this much is clear. Okay, when the class will started, I will revision you people, so better you try to solve this one. This is about the classical mechanics. In next class, the very important questions, that is D'Alembert's principle and Lagrange's equations from D'Alembert's principle. One 5 marks question, one 10 marks question. That is very important. Okay, up to this much is clear, no? So thank you one and all.